Ooh. Okay, good morning. Welcome everybody to the doctoral meeting of Javier Corbelle. Javier Corbelle is a PhD student that works in natural processing language under the supervision of José María Alonso Alberto Bugarín. Today's talk is entitled Dealing with Hallucination and Omissions in Neural Natural Language Processing. You have around 30 minutes, so when you're ready.
Let's start. As Danny said, the title of the talk is Dealing with Hallucinations and Omissions in Neural Natural Language Generation, and it's going to be divided into two parts, but these two parts are very related. First, we are going to explain our ongoing research on dealing with hallucinations and omissions, that are the main divergences with respect to the input data of a system that neural energy systems produce, and we're going to analyze the omissions and hallucinations and the impact of these divergences in the generation of energy systems. Later, I will talk also in the second part of the talk about a project we are involved on that is very related with the evaluation of hallucinations and omissions too, because it's about the reproducibility of the evaluations in NLP in general, but is very important in the field of evaluation of NLG systems. So first of all, for the people who is not very familiar with my area of research, there's a big area that is natural language processing, that are all the field of artificial intelligence that studies the interactions between a computer and the human language. And then there are two subfields that are natural language generation and natural language understanding. So I work in natural language generation, and more specifically in data to text. That is, giving a structured data input, generate a text describing this data. This data can be in form of triplets, for example, with a name, entity, and a value, and you have to generate text from this structured data, or can be also in tabular format. That is the case of my research, tabular format. For example, here we have a box score of a basketball match where you have all the stats and you have to describe the stats of the match. So let me explain the motivation of my research. As you probably already know, there are many different large language models trained with millions of parameters that are very useful for some tasks like question answering, chatbot, etc. These models are very good at generating a very fluent variable text, but the thing is, are these models, these neural energy models, trustful enough? Can we trust on the output that this system are giving to us? Is always this content faithful? And can an expert trust on a neural energy model to put it in a production environment? Or you have to revise all the content that is generating this model and check if it's faithful or not. Well, in research, we try to reuse a neural energy model and check what type of errors this model produce in form of hallucinations and omissions. So we analyze this type of errors and check what is the severity of this type of errors, and if the expert on a given field can trust or not in a neural energy model. So I'm going to explain the context. We work in the meteorology field. We had been collaborating previously with the official Galician meteorological agency, that is Meteo Galicia. We also designing a template-based data to test generator that indeed is currently available in the website of Meteo Galicia. So we have a good communication with them, and this provides us the accessibility to data, real data from the meteorological agency, and also expert availability to assess the generated text by a model. So we plan the research like taking the real data from the meteorological agency and then test how to reuse a neural energy models and evaluate the outputs of the model with experts that are the main professionals that can know if a meteorological text is well generated or not, or is faithful or not. So I'm going to proceed to explain the data set we use and the model we reuse to generate text. Well, it is a data-to-text data set composed of real state-of-the-sky data from Galicia, collected during more than 10 years. Here you have an example of a graphical representation you can find in the web. You have the state of the sky for different parts of Galicia. And we have this data set along, well, we have the data of the state of the sky along with handwritten textual descriptions, both in Spanish and in Galician. But in this experiment, we're going to present is the case of the Spanish version of the data set. So there are more than 3,000 records of meteorological tabular data. And the data in the dataset has this format. It's not as in the image, it was only a graphical representation, but we have tables with different zones of Galicia, 32 different zones, and also by period of the day, the value for the state of the sky. So then we have associated to each table in the dataset a reference text that describes the data in the table. Now this dataset is available at the following link that was presented in this work that in the NLG conference last year. And if you want to get it and try it, you can use it as in this link. So now let's explain what was the model chosen for generating tests with this new dataset. We only wanted a neural NLG model to generate text and then assess the text. It must be noted that the objective was not to get a very good model with perfect text. We only wanted to evaluate the impact of hallucinations in the final descriptions. So we only searched for a data-to-text model that was a neural NLG model and transforms-based model. That is the current tendency nowadays. So we searched for a data-to-text model. In this case, it was chart-to-text. Was a model used to describe the data from different charts. Here we have an example of a Liverpool revenue by stream chart and the caption generated by the model. So the input data was also tabular data, as in our dataset, and the output a caption describing this tabular data. It must be noted that this model has a peculiarity that it doesn't learn to generate directly the caption. It's not a fully end-to-end model. Instead, generate a template with some gaps that must be filled with values from the table. It is because the purpose of this modeling was to reduce the apparition of hallucination. So it also fits perfectly with our research that was checking the hallucinations, the severity of the hallucinations and omissions in neural NLG. So with this model, we had to make several modifications because of the dataset. This model was prepared for an English chart dataset. We also had to make some modification in the input data and preprocessing steps. For example, along with the data table, this model was provided with a chart title. We substituted that chart title with a generic title for our use of case that was weather forecast of the in Galicia by period of the day. And we also had to change the name identity recognition that was in English to a one in Spanish. Then we maintained the heart of the model because we wanted to reuse the model. So the training and validation steps were maintaining the same partition of the dataset and the same layers and parameters. Then in the testing and post-processing steps, we made also some modifications, but only because of the language of the dataset. After generating the templates that I mentioned before, you have to fill the gaps with the words from the input data. So we had to replace the BERT model that was filling the gaps, that is only an English version of this model, with a Spanish version of the model, that is the beta model. And finally, we also add some post-processing corrections, mostly for typos. So at the end, we got, within modifications, we got 272 texts for evaluation in the test partition. That was our main goal, getting some text generated by a neural NLG model, and then do the analysis over the divergences. That is the heart of the research. So now let's go to the divergences analysis. That is the important thing in this part of the talk. But first, let me introduce what are the typical evaluations that are made in NLG systems. Normally, there are two types: the automatic evaluations that are metrics. There are metrics that are computed by a computer. They are not human-made, and are based on comparing, for example, a reference text with the generated text. Some based on n-grams like bleu, rouge, or meter that measure the similarity in terms of the repetition of words or n-grams. And there are also some trained metrics that are models trained based on embeddings or on a regression model to rate the similarity of two texts. And then we have the human evaluation that are not as fast as automatic evaluations. It requires a lot of work, but are more reliable than automatic evaluations. So we have Likert scales to point, for example, to scoring a 5-point scale, the fluency, consistency of coherence of a text, then some metrics for factual correctness. But all of these metrics requires a lot of effort, because you have to design the experiment, recruit some evaluators to do it, probably paid evaluators, and then analyze the results. But at the end, this effort is worthy. And finally, we have the error-based evaluation. Probably are the more costly in terms of time evaluations, but also it allows us to analyze different errors in a system, and is the evaluation that we are going to carry over the generated text from the system. So in an error-based evaluation, the first part is detecting different errors that are produced by our model, and then assess the severity of these errors with some human evaluators. So first, we design a divergences detector. We consider as divergences respect to the input data text that is generated and produce omissions or hallucinations. It is omissions when the input information from the data table is not mentioned in the generated captions, and hallucinations when the caption mentions information that is not in the data input. It is the model is inventing the content at all. So we designed this divergences detector that works in the two ways. First, it checks for omissions, checks if all the input values are mentioned in the text or not. If some of them are not mentioned, it's an omission. And then we have a two-level of hallucinations, the detection, when first we ask all the mentioned values in the data are in the data input. For example, here we have the skies will be cloudy. If cloudy is not in the data input, it is an hallucination because it's inventing the content. There's no cloudy in the input data. So it will be a basic hallucination. But we also check for a second level of hallucination that are specific for our context, the meteorological context, that are the spatial hallucinations. Are all the mentioned values referring to the correct location? For example, here we have intermittent showers more frequent in the coast. We only check the coastal zones, and if no showers are mentioned in coastal zones, it is a spatial hallucination, even if there are some showers mentioned in inland areas. So this is a more, an additional level that we're checking for in hallucination. So we apply this detector to the 272 texts generated by the system, and we detected these divergences. In terms of omissions, we detected a lot of omissions, nearly a 60% of omissions in all the text, but we also checked with an expert. They analyzed several randomly selected texts, and he said that in the meteorological field, it's better to summarize the content, omit some content, and don't try to name all the values in the table, because Otherwise, the text will be very repeatable, and is not good for a meteorological generation. So we didn't care a lot about that. So we focus more in the hallucinations detection. We detected 46 out of 272 hallucinations, nearly a 17%. 12.9% of them were basic hallucinations, and the other 4% were spatial hallucinations. But once we detected the hallucinations, we wanted to ask an expert if these hallucinations were admissible or not. How severe are these hallucinations in the context of meteorology? So we designed a form in which an expert had to score these hallucinations in a 3-point Likert scale, pointing if the hallucination is admissible, partly admissible, or inadmissible, and also justify the score, saying something, because not always is very intuitive to know if the hallucination is admissible or not. So we consider admissible a text that is consistent with the meteorological situation and that can be considered as correct despite not being perfect. As partly admissible, we consider a text that is not entirely faithful to the data, and it could refer to the state of the sky values and the associated area more accurately. And inadmissible when the text mentions values not in the data or associated to a wrong area. So here we have an example of the form provided to the expert. In the top part, we have the generated text. It says skies will be cloudy in the morning with cloudy and clear skies and some weak rains, and in the afternoon, very open skies will prevail. Then we have the hallucination that was detected by our software. That was weak rains. It mentioned weak rains, and then in the data values, there are not weak rains at all. So technically, it is an hallucination. But in this case, as you can see, the expert meteorologist rated that as admissible, justifying that no shower should be expected, but with areas of complete overcast, it is not out of place to mention the possibility of some light rain. So some of the hallucinations were rated as admissible. Here we have the results. Let's take a look to the admissible ones. In total, we have 12 out of the 46 analyzed hallucinations that were rated as admissible, which is pretty surprising. I suppose it's because of the context, but it's surprising, at least for me. We cannot forget that there are also nearly a 40% of inadmissible and partly admissible hallucinations. But in the main of the rated as admissible cases, the meteorologists say that it was because of the contextual information he has, plus the background on meteorology, and also the common sense reasoning. These things are three things that our model was not trained on. The model was only trained on input data and final text. So all this contextual information, meteorologist background, and common sense reasoning, there are things that only meteorologists have, and our model doesn't have, but it generates some content that is sometimes admissible in at least in the context of meteorology. So let's go with the conclusions and future work. After doing this experimentation, we find that reusing a neural model from scratch, as we did, is not a very trivial task. Probably trying an approach like fine-tuning a large language model or something like that will be better, but there are not so many data-to-text systems that do that. So we did it, and due to the adaptations we made with the Spanish data set, etc., it was not a trivial task at the end. We also found that the lack of domain knowledge produces unfaithful content in most of the cases, because there's no domain knowledge in the system. There's a lot of hallucinations and also omissions, despite the omissions are not the most relevant part of this research. And depending on the context, we learned that hallucinations can be also admissible, because 12 of them were rated as admissible by experts. But coming back to the first to the first question, we ask ourselves in the beginning of the talk: can experts trust on neural NLG models? Well, at least meteorologists don't trust yet. They prefer less natural but reliable tests. They don't want very variable tests with a lot of naturality if the texts are not reliable. So the conclusion is that neural energy models probably yet not are reliable enough yet to put it into a production environment. Then, as future work, we plan to improve both the detector and the data-to-text system. We want, in the midterm, to enrich the system and also the detector with meteorological knowledge, a meteorological knowledge base in agreement with the experts, add more spatial references to detect hallucinations, probably from more specific zones, also temporal references, try to, with the detector, check another level of hallucinations in terms of the hallucination is in the morning, in the afternoon, or in the night, and also try to fine-tune some large language models to see if the results are different or not, and if we can if the pre-train of this large language model can be beneficial to the generation of new meteorological texts. In the long term, we also plan to include temporal knowledge in terms of historical knowledge. This way, if the model has some knowledge about the historical situation of Galicia, can know when to use some state of the sky value, independent if it's mentioned or not in the input data table, and to have a bit of meteorologist expert knowledge in that sense. So it was the conclusion of the first part of the talk, and now in the same line of evaluations, I want to talk about the reproducibility of evaluations in NLP. As we saw before, it's very important to make human evaluations over the NLG systems. It's not enough with automatic detector or some metrics. We also need human evaluations, and reproduce these evaluations and check if the results are the same is very important. And now we are involved also in a project called Reproducibility project that I'm going to talk now briefly, some experience we have with this project. So first of all, what is reproducibility in NLP? Well, for the findings of a study to be reproducible means that the results obtained by an experiment should be achieved again with a high degree of reliability when the study is replicated. So in terms of evaluations in NLP, it's also to reproduce the evaluation in the same way and get similar results. And the Reproducibility project has a clear goal, that is the development of a methodological framework for testing the reproducibility of human evaluations in NLP. There's around 20 labs working in this project. We are part of this team. And during the last months, we were involved in different tasks. This year, the lab task was to giving a paper with a human NLP evaluation, try to reproduce the evaluation with the same conditions, and then compare the results obtained in this evaluation. So let me explain what was the common approach to reproduce the experiment for all the labs. First, we had to familiarize with the experiment and resources of the original paper, plan how to repeat the experiment in a form as far as possible identical. If participants were paid during the original experiment, calculate a fair payment, complete the human evaluation data sheet. That is a very interesting document because when you do an evaluation, normally you start doing the evaluation, then you change some parameters, then you see once the evaluation is done, you choose how to analyze the results. In completing this sheet, is very interesting because you have to put all the details of the evaluation, how it's going to be carried, all the settings you are going to choose, and how the results are going to be analyzed before performing the evaluation. So this way, if then more researchers want to reproduce the evaluation, you have all the details in the heads, the data sheet. Then you have to identify the type of results reported in the paper, numerical, qualitative, etc. Carry out the experiment exactly as described in the heads, where you have all the details in the pre-registration file. And finally, you have to report the results of the reproduction of the evaluation. This year, the results of different labs are going to be published in the HumeEval workshop at RunLP 2023 in Bulgaria. And if you are interested, you can check the link of the workshop. I'm going to talk about what was our task in this reproduction experiment. And the task was to reproduce an evaluation made with Amazon Mechanical Turk. That, as you probably already know, is a crowdsourcing platform where you post some work and you can ask for worker requirements, and they respond to your questionnaire, and you pay them because for the results. So we had to replicate the same worker requirements and settings as in the original paper. Some of the worker requirements were having a minimum of 1,000 previous hits approved. A hit is a human intelligent task. That is a task inside of the context of Amazon Mechanical Turk. We also had to put a requirement of 98% approval rate and only restrict to English-speaking people. So we had to replicate this in the same way as in the original paper. And the only thing we changed was the payment that was recalculated given the minimum current wage that was currently. So let me explain some issues we had during the experimentation. When we started the experiment, we had to request approval for the University Bioethics Board to start this experiment. As always happens when you involve persons in your evaluation or whatever study you carry out. So to request the approval, we had to fill a form specifying all the details of the experiment, what type of platform you were going to use, etc. And in the first interaction with the university, they denied our experiment because we should avoid these non-regulated employment platforms and try to use other platforms that are intended to support the research, as for example, Prolific. Well, after that, we entered into a discussion with them, explaining that it was a reproduction task. We have no option, and we have to do it the same way as in the original paper. So they finally accepted, conditionally to consider the above recommendations for future experiments. We say to them, okay, in future experiments that we can choose, we will not use Amazon. But, well, it was a first issue we had just to start this experiment. Another issues regarding Amazon Mechanical Turk were about the worker requirements. Well, let's remind that our worker requirements were a minimum of 1,000 hits and a 98% approval rate to get to our work and do the task. So we posted our work And after a few hours, a very kind worker contacted us saying the following. Just a heads up, posting work with insufficient qualifications tends to yield some terrible results. I suggest making the qualification 10,000 approved hits. Okay, it seems that our qualifications were not enough to get good results. But again, we explained the workers that, okay, but it's a reproduction experiment. We have to replicate the condition and we cannot choose right now, but thanks for the advice. But we took the opportunity to chat with him, and we also asked him about a worker requirement that we were not using in this case, that is the master qualification. When you enter Mechanical Turk and you want to post a work, one of the worker requirements is require a worker to be master. And we didn't know what was a master worker. And we also check in the website of the Amazon Mechanical Turk, and they don't explain clearly how do you get this qualification or what are master workers. So we asked him, what is a master worker and how do you get this qualification? The answer was pretty surprising. He told us that Amazon is notoriously tight-lipped about the master qualification, that as far as all we know, it's some 8-year-old algorithm cooked up by the employee who has long since left. So they don't really know how they can get this qualification, and Amazon is not going to tell anything, it seems. And the master qualification has only been issued to a couple dozen people since 2019, while previously it was probably a few hundred a year. That was surprising to us, the lack of transparency, even with the workers, that we expected that with us, okay, but with the workers. So it was another issue we had with using this platform as a first time in Amazon Mechanical Turk. So now I'm going to close with some lessons learned during the experimentation in this reproducibility experiment. Well, we learned that reproducibility of evaluations requires a lot of details in terms of, I consider that the paper we were reproducing was well detailed in terms of the evaluation process, the requirement, with the worker requirements, etc. But despite that, we had to contact the author asking for more details to be able to carry out a proper reproduction. So it made me think about how detailed are we when we write a paper especially in the part of the evaluation. And I encourage people to be more scrupulous in terms of explaining how the evaluation is carried out and to get the same results in a possible reproduction of the experiment. Then we also learned that Amazon Mechanical Turk is a powerful tool to obtain human responses in a short period of time. We got all the responses in a few hours, probably because of the low worker requirements we choose. We don't know, but also has its drawbacks because there are some ethical issues that must be considered, like the no regulation in the payment. You can pay for per task whatever you want. You are not you don't have a minimum payment. There's also lack of transparency in terms of the master qualification that we saw before. All these things probably lead to a not very good reputation. As we saw, the university, when they read Amazon Mechanical Turk, they say, no, experimenting with Amazon is not okay. So I wanted to show that issues because I think they are very interesting. I want to throw the discussion of what platforms for crowdsourcing are better than Amazon, or at least with better reputation. Because as far as I know, Prolific is the alternative for researchers, but I think there's no regulation in payments neither. So probably we have to think about developing a new crowdsourcing platform, which is more ethic. That's all. Thanks for your attention. If you have any questions or feedback, I'm open to that.
Okay, thank you, Javier, for your interesting talk. So do we have any questions?
Thank you, Javier, for your clear presentation. And also because I like it very much, the two topics that you presented. So I still would like to know, when you were working with the divergence detector, you use the data from the test set or the validation set? This is what I wanted to know.
In the divergence detector, when you have the test set, you give to the model the input data table, and the model generates a text. So we check the input data table with the generated text. First, for omissions, you check if all the data values are mentioned or not in the text. And then for the hallucinations, you check the other way. You detect the different state of the sky values that are mentioned in the generated caption, and if a value from the caption is not in the input data table, it's detected as an hallucination.
And then, see, if I understood well, is so your future work is about building the model for or a detector for that, right?
Yeah, we want to improve this detector.
Now you have the sample is short, right?
Sorry?
The sample is not high; it's short. So there are not many samples.
You mean the data set?
Yeah.
Yeah, we only have 3,000 records in the data set, but I think it's enough to probably try to fine tune a model using the, I don't know, a large language model. Indeed, we are trying right now with the T5 model, trying to use the pre-trained T5 model, try to leverage that learning of the language that the model has to try to generate less hallucinated text with less omissions. We also have to improve the detector to detect different hallucinations, or probably we're detecting some hallucinations that are not, as we saw with the expert assessment.
Okay, thank you.
Thank you very much.
More questions?
Okay, first of all, thank you very much for the super nice presentation, Javi. It was super clear. I like it a lot. I have a couple of questions about the evaluation of the hallucinations. To which extent you take into account synonyms, or the model is able to?
Yeah, in this first approach, we don't take into account the synonyms because we have in terms of state of the sky values, there's a limited number of values that are possible in the dataset. So, because if you see let me search for, you have different values in the dataset in tabular format, and we have cloudy with shower, cloudy with sunny spells, etc. There's a limited number of state of the sky values. So we only check for these values that are the ones that are in the table. So when you check in the generated text, you only look for these values. Of course, you have some plurals, some synonyms. If you say cloudy with showers, well, we also search for cloudy with rains, that we consider is the same. We have some dictionary trying to search somehow the synonyms, but it's not a synonym in terms of, you can say a synonym of another word is totally different. But here we have a limited number of values. You have to check only for these values to check for hallucinations. It's not as difficult as, for example, when you paraphrase, it's difficult to check if it's the same sentence or not.
Okay, understood. And now that you mentioned paraphrasing, if I recall correctly, at some point you said that meteorologists tended to prefer more traditional models that sound less natural but are more reliable.
Yeah.
Have
Right
you
now,
considered the idea of maybe using those, those outputs from more traditional models and then employing a large language model to paraphrase them in order so they sound more natural?
yeah, we also plan about these generations for a template-based model. Use it to train another model. I mean, use this text as a reference and have a bigger data set. That because right now we have a 3,000 record data set that, as Alejandro pointed, is not a very good, well, it's not a very big data set. And we also plan to probably reuse this template-based generated text to retrain another model and have a bigger data set.
Okay. And now just my last question, because I think that you left us all in a cliffhanger. What happened with the paper? Was it, were you able to reproduce it?
Yeah. I was able, but I got slightly different results, at least in one part, because, sorry, I forgot to explain that the evaluation was about, indeed, it was about boxes scored like this, more or less. It was tabular data from basketball matches, and the people in the evaluation had to assess how many of the facts in the text were factually correct or not. It is are contradicting or are supporting the data on the table. We got very similar results with the number of supporting facts, but a slightly different with the counterfactual, with the contradicting facts. So more or less, we were able to reproduce, but the results are not the same. I suppose it depends also in the type of people that enters to the task is different, because the experiment that was run the original paper 2 years ago. Suppose it's very difficult to get the same profile of people answering the same questions.
How many participants?
It's not about participants, it's more about tasks, but I think more than 100 different participants. But we had like 300 different tasks.
Okay. Thank you very much.
Thanks.
So first of all, thank you for your talk. And more than a question, I have a collaboration proposal for you. So I have actually thousands of questions, but I actually wanted to address Lorenzo's question that in my approach, exactly what we do is we have like an intermediate representation of a text, and then we use a large language model to generate like more fluent text. But in the last submission that we did, exactly the answer from the reviewers was that how do you evaluate that this last step of using a large is actually faithful and truthful and supports the this intermediate representation that you have. So I think that this approach is really interesting and it's really needed right now. So thank you very much for your talks.
About the second part of your presentation,
Yep.
this is a very general question that probably is not for you, but it's a curiosity, because it's about issues in the reproduction of the reproduction studies, right?
Yeah.
The thing is, how did you select the reproduction task?
I don't know, it was selected by...
Yeah, and the specific paper, because in the end...
In the project, they have selected papers.
Okay.
They have a filter of more than 1,000 of papers that have enough details to at least start to reproduce the experimentation. I mean, the evaluation in the paper, because the main director of the project has been, I don't know, a lot of months selecting different papers that are suitable to reproduce or not, because most of them, they don't have enough details or the authors don't respond, they don't answer. because the director first contacted with the authors to check if we have availability to email them, because there are many doubts. When you start to reproduce the experiment, you notice that there's not enough detail to reproduce the evaluation.
I missed that part because somehow this research is a case study. Even if you run an experiment, actually it's a case study because you are reproducing a small sample that is, in this case, one study. And then it's important to know how it was selected.
Yeah, the other labs had other reproduction experiments with other evaluations, but the selection process, I know it was very tough, and they are planning for the next year new reproduction tasks. I also emailed the director of the reproduction project, and he told me he was like checking more than 1,000 of papers.
Yeah, very interesting.
Probably finally they will get like 50 that are probably suitable to reproduce.
Good job.
Thanks.
Yeah, so I'm gonna make a couple of questions too. So first one is, I checked your input data in your slide for the meteorologist prediction. So I saw that all of the input data are discrete data, like qualitative data, like cloudy, partial cloudy, showers. So have you considered using like floating data, like probability of rain, humidity, this kind of input data, or does it complicate a lot the problem?
No, indeed we have access to this data. We have data from not only the state of the sky, that is the experiment. In this case, it's only about the state of the sky values, but we also have winds data, probability of rain. We also have access to, I don't know, whatever, a lot of data, meteorological data in floating values, discrete values, categorical values. We have different data, but the first approach was with the easier data, that was the categorical one. Probably with other data, we couldn't do the divergence detector. So we wanted to analyze the hallucinations and omissions. So it was our first approach, but we also plan to add at least the most common variables in the meteorological field, as is the rain, the wind, the state of the sky, the wind, the probability of rain, temperature. We plan to try to do some experiment with also more variables.
Okay, nice. And the second one is more like a general curiosity. So you said that meteorologists do not trust these models to be working on a production environment, but still these kind of models are very useful for experts. For example, for time saving, like I use ChatGPT a lot to generate Python code. And I think that that's useful if you can test and validate the output of these models. But still, a non-expert cannot trust these models to get important information. So do you think we are very far away from these kind of models to be useful for non-expert people? Or do you think that we will never reach that point?
It's a difficult question.
Yeah.
Well, we know we all think about it because ChatGPT was like, wow, incredible. I checked everything in ChatGPT. I tried to ask everything in ChatGPT, but we know it's not faithful enough, and we can use it, but knowing that sometimes the content is not reliable. We have to assume that, because nowadays, as you already know, it's not possible to have always reliable content, have answer to everything, and always reliable. I think is not right now. It's not possible, but probably we need to develop something to do this fact checking after the generation of the system, probably. So at least detect the most the errors that are very big. I don't know. It's a difficult question. It's a generic one.
Okay, thank you. Any more questions?
Well, congratulations on your presentation. It was fascinating. I was just wondering, those results about omissions and hallucinations were only about dataset and the generated text in Spanish, not in Galician, right?
Yeah, it was only in Spanish. Now we have some tests with the T5 model we are trying also in Galician.
So could you maybe make a prediction about, well, the emission percentage and hallucinations? Because I suspect that in Galician it could be slightly increasing.
Well, in the first test we have with T5 model, you probably know the T5 model is a text-to-text model, it's not a data-to-text. But we made some adaptation to give the model like a prompt in a text format. It's generating even less hallucinations, at least measured with our detector in the same conditions, less hallucinations than this model. So
surprising.
Surprising, even in Galician, because the T5 is the multilingual version of T5, and it has, I think, there are more than 100 languages in the dataset which is trained the T5, and the Galician is like the top 40. So it was not so bad to be in the top 40 of the languages.
Not so bad at all.
Not so bad. And the generations are quite good. You look at the generation, well, it seems like, yeah, very natural text with no Spanish words. That is very common when you use a multilingual data set to generating Galician with the Spanish words.
Exactly. Well, thank you so much.
Thank you very much.
Okay. If we don't have more questions, I think we can conclude this talk. And thanks again, Javi, for your nice talk.
Thank you very much.